Welcome to Software Testing Course Module 1 Introduction. This is the first module, and in this course, the next module that we want to cover is software life cycle and role of testing, and so on. So let us first try to understand the objective of this module, which is the introduction. So first we'll try to understand what is software testing, and then we'll go through an example of software and test it out. And then we'll try to understand what to test, why to test, and how to test. And subsequently, I'll walk you through a typical testing workflow, and we'll walk through some testing terms and definitions, basic test process, what is software quality, exercises, and then I'll touch upon the career in software testing. And finally we'll sum it up and have an assignment, and I'll give you a brief about the next session. Okay, so let's first try to understand what is software testing. Now if you look at the term software testing, there are two words in it. One is a software, another is testing. So what does software mean? So software is a computer program, as we all know, and it is a set of instructions. Now that is one way to look at it. For example, a simple hello world program written in C language or Visual Basic. So that's a computer program and a set of instructions which, when executed on a computer machine, gives you the intended output. In case of a hello world, it will print on console or throw up a message box saying hello world. Now, more important to understand is the purpose. So, if you look at the web browsers, let us take the example of Firefox. So, Firefox again is a computer program, and but what is the purpose of Firefox? The purpose of Firefox is for a user to enter the URLs and see the web page come up. That's a basic purpose of web browser. So that so it takes the input and gives output to server requirement. So the input here is the URL address, and the output is the rendered page on the viewing area of the Firefox application. The next key thing about software is for whom this software is. That is, the people and the stakeholders who are using it or involved into it, and definitely it gives them some value. That's where they are, wanting to have this piece of software. So, one way to look at software is to look at it as just a set of instruction. The other way to look at software is that what is the purpose of this creating of this software, and uh, who are the stakeholders involved into it. So that is very important. So Firefox is, as I just shared with you, it is for general users and for web browsing, and they can enter their URL and see the web page. On the other hand, if you take MySQL, so MySQL, the purpose is that it will it will create databases and store data inside it. So people input is that they give commands to create a database and also to insert database. The output is that you can extract information using queries later on. Now, who are the stakeholders? So stakeholders are all those people who are planning to archive the data or store the data in a database. So they are all the values. They are all the people who are the stakeholders for this application. Now that's when the product gets rolled out in the market. Prior to that, the stakeholders are, let's say, the management. So who are looking forward to seeing that this application is made to the requirements and then successfully rolled out to the users and customers. So So at the moment, let's not go into the engineering part, but let's just focus on that. It is a computer program and it is serving some purpose for some people. And what is testing? Testing is, so first of all, the users who are going to use the product, they want a good quality of the software, and so an activity to get that information about the quality is something that we are interested in. That is, we want to compare against the requirement, um, and also we want to reduce the risk of the delivered code. So for example, the Firefox is application is built against certain requirements, and let's say in bookmarking, one is in URL address bar, one is that you can render the page, another is that you can create favorites out of it, so like that. And then there could be different kind of URLs, so you can even do FTP through that, or HTTP or HTTPS, all those. So and then there is this set of requirements that when I enter something in the URL, if it is an HTTP, it renders the page. If it is FTP, it will connect me to the FTP location, or if it is local folder hierarchy, then it will open up the local folder hierarchy, like that. So the 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 testing part is that we know what the requirements are, and then uh, comparing against that requirement, whether it is coming up to the mark for that requirement or not, is one of the activities of getting the information. And and subsequently, when this product gets rolled out into the market, uh, we expect, or the users expect, the functionality to be working in a certain way, as the requirements shared, or the features that shared publicly with the users. So when they start to use it, they should not face any anomalies, and hence, to take care of that and reduce the risk of having left out any bugs in the code, is the reason that we need testing. So uh, so that's the basic premise of software testing. That is, we have a computer program serving some purpose for some people, and they want a good quality, and hence we need an activity to get that information about that quality, and that is by comparing against the requirement and ensuring that there is a reduced risk of the delivered code. You can find more definitions at the Association for Software Testing Dictionary at the link given below. So you can have a look at that. Now let us take the example of a feature of Firefox. So if I were to take this feature, yeah. So here is a list of all the features. So let me quickly so here the lot of options about search which they are given, and yeah, and then here's a simple description about search and find. The find feature appears with simple keystroke. Search for a word or phrase on an open page, highlight the text before using the feature, and find opens pre-filled with your selections. See all the instances of your search at once, or scroll backward and forward through any appearance. So if you see, if I do this is the find, and if I do control F, it comes up. Now if I say putting anything in this, let's say I put Firefox, right? So okay, there are no Firefox entries in text over here, so let me take up something else. Let us say web. So there are a lot of these web things, and I say highlight all, so it will highlight all the occurrences of web in this on this page. So it's over here, it's over here, like that. So this is the basic functionality of find. Now, so now when people tested it out, so they reported a bug, and the bug is at this location. Let me show you this bug. So since Firefox is an open source tool, and when we say open source, that means its source code and everything is available uh, freely and openly, and it's not a proprietary software. For example, like Windows, Microsoft Windows operating system is a proprietary and closed source. Uh, so in contrast to that, Firefox is an open source code base, and and a lot of people in their free time contribute towards building up various bits and pieces of Firefox and contribute to it. Now, similarly, all its project details, features, and bugs are available online. So the link that I have opened up is showing the bugs for Firefox, and so you can select from here open bugs or all bugs and choose the product. So for example, the product is for us Firefox, and we can search all of them. So okay, so if fonts field, I can say so it will give me a list of the bugs related to uh, Firefox. Yeah, there you go. So it has all the bugs related to Firefox. So let us take a look at one of them. 481002. Opening the find bar should add a check mark to the edit find. So let's try to look at this bug. 418002. Yeah, there is this bug. Okay, so it has opened up this bug, and if you look at this, so it is opening the find bar should add a check mark next to the edit find. Now what does this mean? So here are all the details related to the bug, the environmental details. So let us go to the description of the bug. So it says uh, if the find in this page bar is active, add V next to the sentence in the menu. So what does that mean? So he goes on to ask, you mean the check mark? Which menu item? Edit find. He says yes, find in this page. So for example, it is there, but the other it is over here. But the other way to invoke it, that you can go over here and see the find is there, right? Now what it says is that if I, for example, uh, do away with this, then it is fine that there is no check mark against it. But when I click this, then it should come as check. Uh, like how I'll show you. For example, this kind of a checkbox, that navigation bar is there, tabs in the top are there. So this kind of a checkbox should come over here. So this is what the bug is. Now it's a very uh, yeah, simple bug, just to illustrate that the feature is there and the implementation as to how it should be there. Now of course, in the feature description, this requirement is not there, and if you go and look at the bug, uh, so this part is debated in the sense that it says, interesting idea, do you know any other apps that do this, or for temporary toolbars such as find bar? Safari on Tiger doesn't. So no, I find it while testing Firefox, then he writes. So and then he basically goes on to add further comment. So if it is clearly defined in the requirement, then there is no ambiguity. But if it is more of a kind of uh, uh, a kind of a issue which is not related to the requirement. So this is one of those issues. Now let us look at during the course of testing, that when we say what to test, what does it mean? So it means first is that who are the stakeholders and what is their context, and based on that you would decide what to test. So it could be functionality, features. So if that is the main context of the users, so then maybe the launch time of the application doesn't matter to them. So for example, it could be, let's say, a desktop photo editing application or publishing software. So if it takes, let's say, 2 minutes to load, people will not mind it. uh, and because their context is that the functions and the features of the software should be uh, really rich and help them to do their job better. So that's their focus, because their livelihood depends on that tool and those features. So the context of the stakeholders, keeping that in mind, so what is you plan your what to test. So the context could be like functions or the features, or it could be non-functional, that is usability and performance, or security or localization, etc. So and the context can vary from stage to stage. That at let's say after 4 or 5 years of stabilization of the product in the market, the users are comfortable with whatever features are there, and they are not looking forward to any new features. But what their context now is that the performance is not good in this tool, so the performance needs to be better, like that. And then of course, what are the environments on which the testing has to be carried out, as in the different operating systems, different languages, any other third party integration, all that. And also the hardware configurations, that is in terms of what architecture, hard disk space, RAM, processor speed. So all these are the environmental things that we need to determine. The next question is why to test. So if you look at it, stakeholders want value that drives acceptance and hence the business. So the stakeholders, if we look at from the user's perspective as stakeholders, then these users are using your software to add some value to their work, and and if they get that value, they will accept the software, and hence it will go and impact their businesses. So the users are looking for the value, and if they see value coming out of the software, then it will drive the acceptance from the user community for that tool, and hence the business of that tool. Now testers need to look for the perspective of these different stakeholders, and they could be users and customers, they could be even management. So the team in which you are working, the management have certain viewpoint about this project, and they are looking for that kind of a value. So the management for a tester is also a stakeholder. Developers definitely are another set of stakeholders. The other thing is that the company's reputation on quality is at stake, and hence its valuation and return to users and customers and investors and shareholders. So if you look at it, uh, if the software that is shipping out is not of good quality, then the company's reputation is at stake. Now, well, the company's reputation is at stake either ways, good and bad. If the quality is bad, then it's bad. Then if the quality is good, then it is good. And hence, so based on this, the perception about the company gets built up, and hence the valuation of that company. because accordingly the share price of that company will go up or down, and this will drive the valuations, and then the users and customers who are using those products will start to, or who want to, go and try out your software, they will start to shy away, and also the investors and shareholders. And if it is good, the reputation, then automatically the users and customers are driven towards the software, and also the investors and shareholders keep investing in the company. The other aspect to look at is the cost and the revenue impact. So you might have heard stories like Honda recalling their vehicles, Toyota recalling their vehicles. So what happens is, due to some glitch. Now this glitch could be mechanical, or at times it could be the software which is embedded on the automobiles, that so that impacts the uh, 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 so so the software that gets embedded into the automobiles enables the overall functionality of the functioning of the car. Now if there is a bug in that, then the functionality, there will be compromise in the functionality, and hence the cost of recall and then fixing it and then moving it out is quite high. So it is very important that we do extensive testing at our end to catch as many bugs as possible. So there is a cost and revenue impact. The revenue impact we have seen in the example. The cost impact is that when we have to do the rework, so there is additional cost that comes up, that we have to incur. Now, so there was a study done a long time back by NIST in United States, and so what they found out was that every bug fixed late in the cycle causes higher cost addition. So they had look at various companies, and they did extensive research, and then they came up with this conclusion. So so if you see in the first column, it is cost to fix coding defects in different stages. So what are those stages? These are coding phase, integration phase, beta, and release. So that's one. And then cost to fix in terms of R to fix, and in terms of USD. So if you see, if you find a bug in the coding phase, the average R to fix was around 3.2, and cost to fix is around $240. In the integration phase, the cost to the hours to fix goes by almost three times, so 9.7, and the cost to fix almost doubles to $728. Now at the beta stage, it reaches to 12.2, and the cost to 915, and similar at release it is 14.8 to 1100. So if you see, if you find a bug in the release, then the hours to fix is almost 5 times, and so is the cost to fix that issue. So and then if we plot it, we can clearly see that moving from a design stage to the deployment stage, the cost of fixing a software bug increases. So hence it is very important to find bugs early in the cycle and fix them. The next question is how to test. So let me demonstrate it by an example. So let's say there is a search field, and say it takes two characters at position P1 and P2. So here is the search field, and P1 and P2 are these two locations, and it takes two chars, one char in P1, another char in P2. Now the possible values for P1 and P2 could be, so P1 can have 26 characters, and they can either be small cap or upper caps. Then each one of them can have 10 digits, and again each one of them can have 6 kind of special characters and a blank character. So if we add up just these possible values, it will be 52 plus 10 plus 6 plus 1, that makes it 59, and the total combination of filling up these P1 and P2 would be then 59 into 59, that is 3481. Now this is a very simple thing that we have two fields. However, if let's say the field is of 10 characters length, then this number will be 59 raised to the power 10, which is going to be like this huge number. And testing this out, this huge number, is, like, it's almost next to, I would not say impossible. You can do that, but it is impractical to test it. So as the number of combinations get complex, this number gets even bigger, and hence testing this is not practical and advisable. So we need a smarter way to test it out, and hence we need to understand about testing concept and test case design techniques, that as to how to design the appropriate test cases for various situations. So let us look at another example. Consider a person moving from Delhi to Ahmedabad and then back to Delhi. So he, let's say, moves by road from Delhi to Ahmedabad, and from Ahmedabad back to Delhi, he takes a flight. So now from Delhi, so he has the following options. So either he can go to Jaipur or he can go to Agra, and then from Agra he can go straight to Ahmedabad, and from Jaipur he can go to either Ajmer or to Kota, and then from Ajmer he can either go to Bhilwara or to Udaipur, and then from Bhilwara he can go to Ahmedabad, and from Udaipur he can go to Ahmedabad, and similarly from Kota he can go to Banswara or Ratlam, and from Banswara he can go to Ahmedabad, and from Ratlam he can go to Ahmedabad. And from for all these paths, when he reaches Ahmedabad, he can take the flight back to Delhi, and then again see what path he has to take. Now uh, uh, let us take the case where he has to make only one trip. So how many ways he can reach Ahmedabad? So it is clearly 5 ways. That is, either he can go to Agra and straight to Ahmedabad one way, then he can take to Jaipur, Ajmer, Bhilwara and Ahmedabad. This is second way. Then Jaipur, Ajmer, Udaipur, Ahmedabad, third way. Then Jaipur, Kota, Banswara, fourth way, and then Jaipur, Kota, Ratlam, fifth way. So if he has to take only one trip, there are 5 possible ways he can reach Ahmedabad. Now let us say he can take 2 trips. So first he takes a trip. There are 5 ways he can take the trip. Now he comes back. Now again he has 5 ways to go. So let us say if he had taken the first one as Jaipur, Ajmer, Bhilwara, Ahmedabad, and then back to Delhi. Now again he can take the trip to the path like Jaipur, Ajmer, Bhilwara, and all the 5 options. Uh, so if you were to write, if he was taking 2 trips, right, then the total number of combination becomes 5 into 5. So, and again if he has to take 3 trips, then the total number of combination becomes 5 into 5 into 5. So if we were to take 20 trips, let's say, then the possible ways are 5 raised per 20, like that. So hence the total number of ways which are possible are 5 plus 5 raised per 2 plus 5 raised per 3, and so on. So it will be a huge number, as we can see. Now let us give each one of these a character, that is caps A, caps B, cap C, cap D, E, and see how this kind of a thing can happen in a software. So if we consider a software which says if A, that is if I go back, so if Delhi, then either you can go to B, or you can go to B, or you can go to C. So that is uh, either you can go to B or you can go to C. And similarly, if you go to B, then you have uh, either you can go to so from B either you can go to D or you can go to E. So let's go back. From B either you can go to D or E, and this is what the program says. From B either you can go to D or you can go to E. And if you plot this program in terms of node and connecting lines, which is called the graph, so we can clearly see that from A it can go to either B or C, from B either it can go to D or E, from D either it can go to F or G, I, J, K, C, and from K back to A. So it shows all the if conditions and the various paths that are possible. So this is typically what we can have a kind of a situation in a software as well. So then if we compute this all for the example that I showed you just now, this number would come to around 100 trillion. Now say to write and execute and verify a test case, it takes 5 minutes. So that is to test one possible thing, a path, it takes 5 minutes. So it will take a billion years to test the whole of this small program. But if it takes 5 microseconds, then it will take around 19 years. So it can be made possible by putting a network of computers together, but it is impractical, and we need to use certain techniques and define the scope of testing. So to do an effective and efficient testing, so we need to first learn those techniques and then apply them on our projects, whereby we eliminate this humongous number of test cases and derive the most effective test cases for testing using these various test case design techniques. And also based on these combinations we need to define the scope of testing, that is clearly define what are the operating system, what are the languages, which languages are high priority, which languages are low priority, so that on low priority we can reduce the number of tests that need to be run, and so on.